National Congress on Emerging Technologies and Artificial Intelligence in Modern Engineer, organized by the Faculty of Mechanical Engineer at the National University of Engineer. My name is Abigail Rodriguez, and I am a member of the organizing committee. We are pleased to warmly welcome Mr. John Bohr, who is already connected. We sincerely thank you for your participating in this event. John Bohr is CEO, and the topic of today's presentation is utility pole inspection using ground-based photography. Mr. John, please go ahead with your presentation.
Right, thank you. And good afternoon, everyone. Yes, I will be talking about utility poles and the process of doing inspections. Let me start with a little overview. This slideshow is about 10 slides, and then I do have a short video. Hopefully I can play that. I will do the slides first, and then hopefully I can play the video. That's a little demonstration. So let's get started. In the United States, there's about 200 million utility poles, and most of them are wooden poles. And there's a process to do inspections every 5 to 10 years. In some parts of the country, it has to be 5 years. For example, in Florida, where there's more rain and there's different weather, you do more often. And in other regions, like in Arizona, where I live, it's the desert, and you only have to do every 10 years. That means that every day, 100,000 poles are going to be inspected, which means there's at least 2,000 people working that job full-time. And it's only for the United States. You know, if we have Mexico and Peru and Brazil, there's like millions of poles and thousands of workers. So the problem is that all these inspections take a long time. They can take, you have to visit, you have to look, you have to fill out form, and it takes a long time. It can take 10 minutes for one pole, or sometimes 15 minutes. So we were trying to come up with a system to make this more efficient. And I think we did that, and that's what this presentation is about. So we're using AI to help with the inspection process. So instead of an inspector visiting each pole and filling out a form, we just take pictures. That can be very fast. And then we use an AI model to analyze the photos and then create a report. And as you can see on the slide, we can do at least 5 times more of the work compared to before. And it will reduce the cost of each inspection dramatically, sometimes up to 75%. Now, there's other companies that do inspections. A lot of them use drones. I'll show you that next. Let me tell you how it works. So you go to a pole, you take 3 pictures or more, at least 3. You can take 10, you can even take more. The more photos you take, the better the quality of the AI will produce a report. And then they get analyzed, then a report gets generated, and then we can show them on a map and on dashboards. So how did we do this? So we were training a sample data set of 10,000 poles for a total of 80,000 photos, and we put them in different AI models. We tried OpenAI, we tried Google Gemini, and we tried Anthropic, and we tried different models, and we were learning which ones work best for this particular use case. And then we ended up with a model from OpenAI, and we ran 200 hours of compute time to train the model. Now, why we're doing it this way? There is other companies, they use trucks or drones to do essentially the same work. The problem is trucks and drones are a lot more expensive. You need, for a drone, you need a pilot, you need insurance, you need clearance from the aviation authority. And the same, a truck is expensive to operate. You need a licensed and a trained inspector, like a technician, to do the work. But taking a picture, anyone can do. And in some cases, for example, in some mountain areas, a truck cannot go. But, you can walk there and still take photos. And then we use standard device. You can use Android phone or an iPhone, or you can use a tablet, as long as it has a good camera. So this is an example of what we did. So step one, you take pictures, and you need to take a few different ones. You need to take at least one of the full view, like the whole pole with everything on it. So you can see the bottom, you can see the cables, you can see the top. Then if there is a label or a sign or a number on it, you want to take a picture of that. Then you want to take a picture of the bottom, so you can see the ground to see if it's wet or damaged. And then you want to take a picture of the top, so you can see all the equipment, like a transformer and the cross arm and the cables and the insulators. And then when you've done that for a whole bunch of poles, you can show them on the map. This is an example of how we show that. The gray circles are the actual poles, and you can see in between are the power lines. And then the poles, the yellow dots are going to houses. And then you see all the little camera icons where the pictures were taken for that pole. And because we're using an Android device that has GPS, we can automatically place those images on the map because we know where they are. Then we feed it into the AI model, and it will create a report depending on how many images are being taken. They can take anywhere between 30 seconds to a minute, and then it will generate a report. And this is an example. So it shows the photos, and then the report consists of 3 sections. One is the pole itself. It gives you a description of the pole and its condition, and it will assign a score to each pole between 1 and 10, where 1 is very bad and 10 is perfect. And then on the next slide, it will also show you the equipment. So it makes an inventory of everything that's mounted on the pole, like brackets, transformers, whatever you can think of. And then by default, because our customer was local, our report is in English, but we tried, and we can also generate these reports in Spanish, Espanol, and also in Portuguese. So here's a continuation of that report. So it has a list of all the equipment. So if you can see it on the screen, you can see there's a transformer, there's wires, there is a communication device. And then at the bottom of that report, it's reading the label, if it can, and also the condition of that label. So then, when you've done that for a whole bunch of poles, we can show them on the map with the score that was assigned to them by the AI model. So here you can see most of them in the middle are a 7, which is a good pole. But you can see there's one at the bottom that's a 5. And There is even a 9, which, is a very good ball. So now an operator, an analyst can look at the map, and now they can start making a plan about which balls to visit for a follow-up. So you don't have to visit all of them. You only have to go to the ones that need work. And then additionally, we can show them on dashboards. So here's an example with the 10,920 poles. And it shows you an inventory of all the equipment and the score of each of the equipment. And the top chart, you can see it shows you the score of each pole and then the number of poles. So most of them are 7 or 8, but there are a few bad ones that probably need, additional follow-up. And the dashboards are live, so you can filter and click and then show that where that is on the map. So you can plan your follow-up work. So in conclusion, and the map that you saw and the pictures that you saw was done in Nevada in the United States. So we did a 3-month trial with those 10,000 poles. And what we did there was the inspectors also did a manual inspection where they fill out the form. And then we used that plus the images to train the model. So in our 3-month trial, they did 3 times the amount of work for half the cost. So they needed half the number of people, but they were able to do 3 times more work. So it was a 6 times improvement, which is, very large cost savings. And then, of course, the goal is to prevent poles from completely breaking down, which will cause a power outage. The results are better than what a human can do because the AI has a lot more information that it can analyze at the same time. And it's always consistent. Like between one utility worker and another, they might have a different opinion. Or maybe they get tired at the end of the day, while the AI model will always be the same. And then, as you could see on the map, you can now prioritize your work, which also has those cost savings. So that was the slides. I will now try to show you a little demo of how that worked. Let me see. Here we go. And this is in Spanish.
Bienvenidos a la herramienta de evaluación de postes de servicios. En esta sesión exploraremos cómo usar esta herramienta para comprender el estado de los postes de servicios en un área específica. Como pueden ver en el mapa, cada punto representa un poste de servicios. El color del punto indica la calidad del poste basada en una evaluación reciente. Para entender qué significan los colores, consulte la leyenda a la derecha. Utiliza una escala del 1 al 10. Una calificación de 1 indica que el poste está en pésimas condiciones, mientras que un 10 significa que está en excelentes condiciones. Los colores intermedios te dan una representación visual rápida del estado del poste. Al usar este mapa y entender las calificaciones de calidad codificadas por colores, puedes identificar rápidamente las áreas donde los postes pueden necesitar reparación o reemplazo. Ahora, acerquémonos y veamos un poste individual y obtengamos un informe detallado de IA. Como puede ver, el informe incluye varias imágenes que el modelo de inteligencia artificial estaba analizando, destacando el estado del poste. La descripción señala un desgaste superficial extenso, importantes grietas en la superficie y quemaduras severas e carbonización. El informe sugiere que se necesita un resistógrafo para evaluar la posible descomposición interna. Esta información nos ayuda a entender los problemas específicos que afectan al poste y qué acciones adicionales podrían ser necesarias. La IA no solo evalúa el estado del poste usando imágenes, sino que también identifica una lista de equipos adjuntos. Esto incluye un brazo cruzado primario, aisladores de porcelana, transformadores de distribución montados en el poste, conductores y un cable de puesta a tierra con hardware. La IA observa problemas como el desgaste en el brazo transversal, el óxido en los transformadores y el óxido en el cable de puesta a tierra. Basado en estos factores y el carbonizado de la superficie y las grietas en el poste mismo, la IA asigna una puntuación de condición general de 3, recomendando una inspección estructural en el sitio. La IA también detecta la etiqueta de identificación del poste 3066. El modelo de IA está entrenado con un gran conjunto de datos de 80.000 imágenes de 12.000 postes y sus componentes. Al analizar estas imágenes, la IA aprende a reconocer patrones, formas y texturas específicas asociadas con diferentes tipos de equipos, incluidas las etiquetas de los postes. Cuando la IA analiza una imagen de un poste, utiliza estas características aprendidas para detectar la presencia de una etiqueta. Puede identificar la forma de la etiqueta, los caracteres o números en ella, e incluso el material del que está hecha basándose en su color y textura.
All right, so that was my presentation. That was my presentation, and I hope the video came across okay. I believe there's time for questions.
Okay, Engineer, we start with the question and answer. Okay, and the first question is, what kinds of defects can these methods detect?
So it's doing a visual analysis of the pole based on the photos. It can detect the quality of the wood. If there is a wood rot, like especially sometimes that happens at the bottom when the soil conditions are wet, it can detect holes in the pole. For example, we found a few examples where there was a woodpecker. A woodpecker is a bird that makes a hole in like trees and poles. It can detect that. It can detect the insect damage, like from a wasps or other types of insect. It can detect rust. So if there is equipment on the pole, like at the top of the pole, there's the cross arm. It can detect rust. And of course, it can detect, cracks in the actual wood. It will also detect if the pole is leaning. But that's a little tricky because that depends on how the pictures were taken. If you take the pictures from a good angle, it can detect if the pole is leaning over or if the pole is up straight. So it can detect, a whole variety of defects.
Okay, that's interesting. The second question are, is it cost effective for rural or remote areas?
We believe the answer is yes. It's very cost effective because traditionally, if you have to send someone out that is a lineman or a technician or an engineer, first of all, these people are more expensive, and you can send, an intern or an entry-level employee to go out and just take pictures. Anyone that can take pictures, they only need 1 hour training to tell them how to do it. So the cost of the person that still needs to do some work is dramatically lower than having to send out, an experienced field crew.
Okay, thank you very much, Mr. John Burr, for your excellent presentation. On behalf of the inter-community of the Faculty of Mechanical Engineer at UNI, we sincerely thank you for your participating in this international congress and for sharing your knowledge and experience. We also thank the audience for their active participation and thoughtful questions. We kindly remind you that the next presentation we will begin